curiosity.
Take a strip of paper and roll it into a tube and stick it down. If you do that and cut slits from the top and bend them down, you can make a model of a plant. And a very ratty model it is too. It looks a bit like a plant, but not much. So throw it away and do this with the tube instead. With your scissors, just cut one leaf shape on one side. That's all you need. But then, if you take the innermost leaf of that set and pull it out, you'll notice what happens. As it grows, it spirals. And that, believe it or not, is a very much better model, because as plants grow, the leaves spiral around the shoots, like these. If you look at the ends of those, look very carefully, you'll see that they're growing in a spiral. Each plant has a different sort of spiral, but they all do it. They've learnt their numbers. In fact, they're all growing to a series which is based upon a Fibonacci series, after Fibonacci, the mathematician who developed it. Well, it's a funny series, and let me show you what it is. If you take 0 and add 1, then 0 and 1 together make 1 again. 1 and 1 make 2. 2 and 1 make 3. 3 and 2 make 5. You see what's happening? The next term is always the sum of the last two. 5 and 8 make 13, and so forth. Well, you can develop that as long as you like, put it over itself like this, and then move the bottom line one space to the left, and you get this series of fractions. And that is the series of fractions the plants seem to know about, because they all grow according to one of those fractions. And the way it works is this. A plant will have the number of turns that is given by the top line, and in that it has the number of leaves given by the bottom line. That's a bit confusing. Well, let's see what happens. A cardboard roll is a good way to show this, because it's got a groove all the way around it, a spiral groove, and so you can quickly tell how many turns you've made by counting up the number of grooves, 1, 2, 3. Much easier, of course, if you colour them in. And I've coloured this one in blue, and I've also put a bit of cotton round there, because that's going to be an important measure. So if I turn that round and make a line all the way down there, like that, and this is what we'd find. We'd have a leaf there, and eventually we'd find one in line with it. Let's say there. And by looking at the series, we could count up the number of turns. That's from there to 1, 2, 3. Find that in the top line, and down on the bottom line is 5, which tells us there would be, in 3 turns, 5 leaves. We could make a model of that. In fact, I've made a model of one a bit more complex. It's the next one in the series. It's a longer tube, and if I start here, I can go 1, 2, 3, 4, 5. It's 5 turns. I'd expect to find 8 leaves. How I find out where to place them is by marking the cotton there and there, taking it off, dividing it into an 8, putting it back again, and making marks on the tube. And I've done that, and this is where the leaves would go. One there, and all the way up in the series. And there I have it. 8 leaves in 5 turns. And that really is a model of some particular plant. I don't know which one or which ones, because many of them will grow to that. But all plants will grow to one of those fractions. And it's an interesting thing to speculate and look at plants and see which does what. Pine cones do it too. So do the middles of daisies. Lots of plants do, and they use all those different fractions. Here, for example, is a model of an elm. That simply does, in one turn, 2 leaves, and they end up pretty well opposite each other. Well, if you go into your garden, particularly into an Australian garden, you'll find very good plants for checking this out. Australian natives have very clear spirals on the end. Mind you, it's harder in practice than you might think. If you have a look at this one, for example, and we start with this leaf, which one is dead in line with it? Is it this one, or that one, or that one? We have to look awfully carefully, and there are minor variations, but in fact, that and that are dead in line. I've counted them up, and there are 13 leaves between that, and sure enough, above 13 we find 8, and there were 8 turns around to get from there to there. So check out your own plants, see if they've heard about Fibonacci.